do a bit of recap. So you've got your 6 rules that you need to remember. You've got your chain rule and product rule. Let's recap here. What is the derivative if you have a polynomial function, x to the power of n? What is the derivative rule for that? Looking at your notes, can I please have... Let's go Ryan. Let's start off from right and left.
nx to the power of n minus 1.
Very good. This would be simply whatever the power is, so n multiplied to x to the power of n minus 1. So that is the power rule. So that's the first rule you learnt instead of doing first principles. Okay, so that's 17b and then 17c and onwards. And then e to the x. What's the derivative of e to the x? Let's go with Max. E to the x, just itself. Very good. What is the derivative of log e of x? Lohit. No. Let's go with someone else. Who knows? Yes, Jem. 1 over x is correct. So the derivative of log e of x is 1 on x. What is the derivative of sine of x? Let's go with Jacob Lowe. Cos of x is correct. What is the derivative of cos of x, though, Jacob White? Negative sine of x. Very good. And then the last one, which I've seen in the recent exams come up. What is the derivative of tan of x? Let's go with Erin. What's the derivative of tan of x? Very good. And what is another way of writing sec squared, Matt? Inverse of cos of x all squared. Very good. Okay, so those are your 6 main rules that I asked you to write down. That's after you learned the power rule, and then that helps you to learn the chain rule. Okay, because this is the format I want you to copy down, not the ones in your textbooks, because then it practices you to use chain rule. What is the rule for the chain rule? So if you want to find delta y, delta x, the rule for the chain rule is, let's go with Ollie. What is the rule for chain rule? Delta y, delta x is equal to?
Delta y, delta u.
Very good.
Times delta u, delta x.
Very good. So the key part here is to introduce a third variable that makes your life easier. And so it ends up that you have to do 2 derivatives. And if you multiply the 2 together, technically it's the same thing as finding delta y, delta x. Okay? So this is your chain rule, which is your bread and butter. And as you can see in most of the questions in here in exam, this is year 12, this is unit 3, and just unit 3 concept here. But you can technically do at least 1 mark out of 40 right now. Okay, if you know your chain rule and your 6 rules. That's as simple as it is. Okay. Then I introduced the next rule recently, which is our last session. We talked about product rule. Product means timesing or multiplication. So if you can see that you have a function or an equation that has 2 things multiplied to each other, or 2 graphs or 2 equations or 2 functions multiplied to each other, you call u and v. What is the derivative rule for this type of function? When you have products of 2 functions, what is the product rule again in the way I've taught it to you? Okay, because the textbooks will write it slightly different. What was the rule, Matt?
V dash, or v times u dash, plus u times v dash.
Very good. If you didn't know, this is the rule. I want you to write it down in that particular order. Technically, addition doesn't matter which order you put it. Normally textbooks would do u v dash and then v u dash, and the reason why a textbook would do that is because it's u dot v, so then they normally write the derivative as u v dash plus vu dash. But over the years that I've taught it, I realized that when students start to do quotient rule, they tend to mix the 2. So I've changed it over the years, and it seems to help students remember it correctly. So for those who are interested, again, you're not going to be required this year to know the quotient rule, but for those who are interested, especially if you're doing these questions here, you can do product rule, but quotient will make it faster. This is your quotient rule. if you have u divided by v, the derivative is vu dash minus uv dash all over v squared. Now, that's why I wanted you to write the product rule vu first. Okay, so when subtracting, it does matter which one comes first in the quotient rule, whereas in product rule, you won't have a problem. But if you mix the two, when you do quotient rule, that's when it goes wrong. Okay, so what's expected this year? I do expect you, and I'm training this group or this cohort to at least learn chain rule, product rule. Okay, so in previous years, they only learned that much, or maybe even less than that, and they only do that. Okay, so we want you guys to practice this section. So chain rule and product rule technically is a Unit 3 concept, but I think you guys can definitely pick it up, and you guys have been doing really well. So chain rule, product rule is what I want you to do. That's how you, these are the rules that you need to know so far. Okay, and don't forget, all of this is just a shortcut. All of this is just a shortcut to do the first principles. That's it. Okay, so in the next exercise next week, I'll start to apply the derivatives. So we'll be looking at straight line equations, how to find the gradient of your tangent line, find the equation of tangent line, find the equation of the normal line, find the maximum, minimum points, all that. This will depend on how good your derivatives are. Okay? All right. So product rule, that's what I want you to be practicing on. For those who've forgotten, I'm going to do one example just to show you, and then you can have a go with the past exam questions here. Okay, so let's do an example of a product rule question. Let's say a typical one that you normally get in a textbook, and maybe sometimes an exam. It might be in one of those there, but it could be 2 sine of x times cos of x. That's a typical one. Okay, here we go. How do I know that this is a product rule? It is not a function within a function. So if you had something like this, I'm going to show you the difference between chain rule and product rule. If you had a question that looks like this, y equals 2 sine of cos of x. See the difference between the two? One has a cos of x within sine. See, sine of x, but instead of sine of x, it's sine of cos of x. This is a chain rule problem. So this is chain rule. Whilst product rule, you can clearly see sine of x is one function. It's written next to cos of x, so that means it's multiplying your second function, which is cos of x. Once you can identify that this is a product rule, so I can say that technically the rule says if you have u dot v, okay, so you can identify which one's u and which one's v. Well, this would be my u, and this would be my v. Doesn't matter which one. Okay, so I'm just going to call the first one u and the other one v. Then I know the rule. The rule states that the derivative should be vu dash plus uv dash. Okay, and that's what I want you to write down. Or remember, it's VU first. Okay? So using our rule, if I let u equal to, so let u equal to 2 sine of x, because that's my first part of the function, and v is equal to cos of x. This is where you use your 6 rules. Let's work it out. U dash means the derivative. So what is the derivative of 2 sine of x? Let's go with Jacob White. What's derivative of 2 sine of x? 2 cos x. Very good. The 2 doesn't get affected. It's a constant, so you leave the 2 there. You only derive sine of x, and that's where you go back to my 6 rules. Derivative of sine of x, you can see it's cos of x. So the answer has to be 2 cos of x. Okay, so rely on the 6 rules. Same thing with v dash. I'm finding the derivative of cos of x. So go back to your 6 rules. What is the derivative of cos of x? Let's go with Zach. Negative sine of x. Very good. Negative sine of x. There we go. So now that I've got my v dash and u dash, I'm going to apply my product rule, which is here. So I'm put it all together and say, all right, well, delta y, delta x, that's what I'm trying to find, should equal to vu dash plus uv dash. So putting together, and I like to write it in this way because v u dash just means I'm multiplying those two together. So cos of x multiplied to u dash, which is 2 cos of x. And then plus u, which is 2 sine of x, multiplied to v dash, so negative sine of x. And here we go. We've got 2 sine of x multiplied to negative sine of x. Technically, up to this step, you are correct. There's nothing wrong at this step. In year 12, you should be simplifying this as simplified as possible. Okay, so I can see that this is going to be 2 cos x times cos x. You can write it as cos squared of x, just means cos of x squared, plus this is now minus 2 sine squared of x. And so if I write it all again, that's 2 cos squared of x minus 2 sine squared of x. Now, technically, yep.
Are you mentioning that the sec squared was sec of x? Like the other one that we said was derivative of tan of x was cos squared.
You could, if you change it into an inverse, you could. In my case, I'm going to, because sec squared of x is equal to 1 over cos squared of x, so I guess you can rewrite it. Cos squared of x would then be equal to 1 over sec squared of x. That's, no. I would say in this particular example, it's a typical VCA question. At this point, there is an identity that you learnt in chapter, was it 14, that we did circular functions? Can anyone see anything that we can simplify? So up until this step, it's correct. The 2, very good. So I would encourage, by the time you get to year 12, or even at the end of this year, in your final answers, you should factorize whatever you can see. Okay, and I'll show it to you when we start doing some of the problems here. I'll show you what I mean by fully factorizing. But you take out the 2. What else do you see? If you take out the 2, it's cos squared of x minus sine squared of x. And you were saying you had your hand up?
Oh yeah, it's isn't it like 2 cos 2x?
2 cos 2x? Can you explain?
Well, I mean, you just first of all, the first expression you can just simplify to sine 2x. Then you just derive that and get 2 cos 2x.
Wait, now I'm confused what you were saying.
Go back to the first, like
This line?
no, opposite. Like the very first one. Yeah, so you can just simplify that to sine 2x.
Yes, we can.
And you just get 2 cos 2x.
But for those who don't know, what rule are you using there? Just for them, for everyone else to understand. What are you doing?
Double angle.
Good. And is that in Spesh course from memory? Yeah. In the Spesh course, if you do Spesh, there's an identity that you can simplify 2 sine of x cos x is the same thing as sine of 2x. Those who do Spesh would normally simplify that. Sometimes your textbooks do that as well with the assumption that you've learnt double angle formula. You search it up and there's about 3 or 4 identities you can learn. Yep. I think leaving it here is fine. Yeah, but if it was addition, so sometimes in the exams, if that was an addition, you can simplify this as an identity from chapter 14. Anyone remember what cos squared of x plus sine squared of x equals to? 1. And that's one of the identities that they will sometimes use, and they might not give you the mark even if you got up to this step, and that means the answer had to be 2. But that's something more of a year 12 question at that point. But up until this step, you're using product rule. But this is minus, so you can't use it. Yeah. All right. that is your example of a product rule. I want you to have a go with the exam questions over here. So in your sheet, it's double sheet. I went all the way to 2006. Technically, I think I could have found a few more earlier, but these ones gives you an idea. It's 40 marks for exam 1. You get 1 hour to do it. And the first page, you can see that most of it is about 3 marks. 3 marks or to 4. 3 to 4 marks out of 40. That's like almost 10% there. Okay, so you can do it. It's designed, exam 1, it's designed for you to get as many marks as you can. So with the current skills that you have, you should be able to do all these questions that I've just set up. The questions with the fraction, like this one, 2007, you can use product rule for this because that's x cubed times, and you can bring the sign of x to the top and then become sine of x to the power of -1. Just means that you have to use chain rule to do this one. But if you have quotient rule, it'll be faster. Okay, but technically you can do any quotient problem with product rule. Okay, so I'm going to go back to the 6 rules in front of you here in case you want to refer to the rules. They are here for you there. Okay, then we're going to have a look at your solutions. We're going to go through each one to see what you got and see whether you can obtain 3 marks or 4 marks out of 40 at this stage.